I went for undergrad to Bard College and I got my master's from the University of Minnesota.
Okay.
I actually stayed with Dominic Argento for a while.
Oh, really? Okay.
He's not the greatest teacher, honestly. Judith Zamont was amazing. She was one of the best instructors I've ever had. She just, you could give her like this chicken scratch scroll of a score, and she like looks at it and she like will have some like in 5 seconds. She's like, well, "Have you considered doing this? Because I think that will help you achieve the direction you want." I was like, "Oh my god." She is just, I don't like her music much. Like, I love Argento's music. I didn't like her music much, but as an instructor, she was absolutely fantastic. Just so good. So, and yeah, Argento is kind of, he's not very nice.
I never heard of him much.
Oh, really?
And then I did when I did my master's, Cincinnati did an entire year.
Oh, okay.
Where they did an Argento opera that no one ever does.
Yeah.
And
was it a Wonderbird talk by any chance? I love that one.
No, it was Edgar Allan Poe.
Oh, okay.
Yeah, I mean it's a great piece. It's just this is not going to get done.
Oh yeah, I think his music is just amazing. He's a great composer. But
yeah.
We called him the Dominator. No, Dominus.
Dominic Argento.
Darius, I think you're thinking of the guy as a composer. I'm a film director.
First class.
Dave.
We've corresponded very briefly.
Oh, okay.
I work at cPanel. You probably know Dan Mui better.
Yeah, I've talked to him a little bit. Yeah.
Yeah. We use DateTime a lot.
Okay. Cool. No, he's saying he works at CMP. No, I didn't.
You didn't work at CMP, but
no, I work at cPanel.
okay, I give up. I'm done. Except I did take Harmony. I almost declared the major, and I got 2 years.
Trying to figure out which is closer. It's fine.
That's how you break the fourth wall.
I didn't know there was a fourth wall. Am I not allowed to walk in front of the podium?
No, I always see it as a wall to break, and that's my own issue, really.
Yeah, the people speaking are not particularly special. I mean, he spoke yesterday. That is example. But the point is, you're just sitting right next to him. It's not anything magical. And
Some people need this explained.
Okay.
See, speaker, clueless. Know it all. I picked up like 24 badges when I got here, but I figured those 3 told the story.
Doesn't begin your cover.
I like to be directed.
I did actually consider playing some music as an intro, but it's kind of weird if I'm standing here. I wanted to play Anthrax's Got the Time. I thought that would just be perfect. Oh yeah, that would be beautiful. When I say play some music, I mean off my iPod, not perform. We have about 30 seconds. No. No. All right, time to start. So my phone says it's 13:30, and since this is a presentation about dates and times, I think I should start right on time. So, hi there. My name is Dave Rolski, and on IRC, my nick is Autark, and you might have seen me there. And it's June 15th, 2012, I think, and I think we're at YAPC North America 2012 as well. So this is Dates Times, Perl and You, but Stephen over there, I was having dinner with him. He had a much better idea for the talk title, How to Get a Date with Perl. So we'll call it that too. I'm a little sick, so I'll do my best not to, cough green phlegm on you, but we'll see what happens. You guys in the front row, you're at risk. So the first thing you need to know about dates and times is just the whole subject is completely nuts because it's this very artificial kind of human created thing, and humans are stupid and nuts, and so we make things that are crazy. So I'm going to talk about some of these issues: calendars, time zones, daylight saving time, my personal nemesis. Well, I have two nemeses here: daylight saving time and leap seconds, which are both just a horrible pain in my ass. So if there's nothing else you take away from this talk, this is the one thing I'd like you to take away from it. Because I've seen so many people try to do their own thing where they're like, I'll just get the epic and then I'll add blah, blah, blah. And it doesn't work out very well because there's a lot of issues, and I'm going to be covering some of those, that make it so that naive approaches almost always fail at some point. So it works for a while. And the worst part is it like works for 6 months, and then February 29th of 2012, oh shit, I didn't account for that. Your code goes down. Somebody was saying this happened to Microsoft Germany. Like they had a bug where it added a year, like it incremented the year of a date and for like the certificate's expiration, and on February 29th, it just stopped working all day because there was no February 29th, 2013. So yeah, there's a lot of things that can go wrong, and the DateTime module hopefully addresses a lot of those for you. So this is my advice. Now you can all leave. The talk's basically done. So yeah. So I'm gonna talk about both kind of concepts and try to just give you an understanding of kind of general date and time concepts, and I'm also gonna interleave that with code. So the first thing we'll talk about is the Gregorian calendar. That's the calendar we all use like day to day right now. So it's based on the Earth's revolution around the sun. And so that's, the time it takes for the Earth to get from one point around the sun, go all the way around and come back to the same point. There are other calendars that have been used historically that will be based on the moon's revolution around the Earth, or some calendars will combine both of them. If you've heard of, for example, how the Hebrew and Chinese calendars will have leap months, that's because they're based on the moon, and the moon, you need to add an extra month because some years effectively have 13 lunar cycles. So anyway, there are other calendars, but this is what basically everybody in the world uses most of the time. The other ones come up, for example, if you want to know when Chinese New Year is, you need to use the Chinese calendar. If you want to know when Ghost Month is, which I'm sure you all want to know, like because you have to burn a bunch of paper money during Ghost Month, very important. And for example, the Hebrew calendar is used for Jewish holidays. There's an Islamic calendar used for Islamic holidays, and I'm sure there's many others that I'm forgetting. The Mayan calendar is used to figure out when the world's going to end, which is probably this year. So here's the basics. So in most years in the Gregorian calendar, we have 365 days. Leap years, we have 366. The beginning of the calendar, its epic, is year 1, January 1st. Okay? There is a year 0, if you depending on how you write it, or sometimes that gets written as 1 BC, 1 BCE. There's lots of versions of this. We may need to tweak the leap year algorithm around year 3000 because it turns out that the Earth is actually slowing down its revolution around the sun. So that's something you might want to keep an eye on in your code. If you think your code's going to be running in about 1,000 years from now, maybe just don't put in some hook for somebody to change that. Yeah, exactly. Perl 6 will take care of this. Yeah, right. So we're going to have a Y3K-ish bug, I think is what I'm hearing.
I need it now because I want people to pay me $1,000.
Yeah, well, there you go. So here's the DateTime module in a very simple usage. So you use DateTime. You make a new DateTime by passing the components to it. So you can pass year, month, day. You can also pass hour, minute, second, but I'm starting with just dates. And then you can ask it for all sorts of information. So you can ask it, you can ask it for the date, and it prints out this format: month name, day name. You can get numbers out of it. You can get it to do formats like STR-F-time formats. There's a much better formatting system it supports called CLDR, the Common Language Data Repository format, which just gives you access to a lot more name information per locale. And so speaking of locales, it also supports localization. It's based off the CLDR data, although it's kind of out of date because need to basically redo DateTime locale, and I have not gotten around to it. So if anybody wants to fund me for 3 months to work on that or something, maybe I can take a sabbatical from a job. Anyway, so you can pass this locale, and it can be a language or a language with country, and it looks it up in the CLDR and finds the appropriate locale. So now when we ask for the month name, it says juin. That's my French. Instead of June, and it changes the day names and such. And it also changes things like you can ask it about what's the first day of the week, for example. That changes by locale. All sorts of stuff changes. By the way, feel free to ask questions if anything's unclear. I may or may not answer them, but you can ask. And as I mentioned, there are other calendars. So we can use the DateTime calendar Chinese module. We make our DateTime object in the Gregorian calendar. Then we can pass it to DateTime calendar Chinese and ask it information. Okay, so what's the Chinese calendar date for today? We can ask it about the cycle and the zodiac animal, and we can get information out of it actually in Chinese. And this works for there's a whole bunch of calendar modules on CPAN. By the way, DateTime calendar Chinese is not shipped with the core DateTime distro on CPAN. There's many, many calendars on CPAN, so you can just download them. You can also create the alternate calendar object directly. It has a constructor besides from object, and you can go back and forth. So we could also have a DateTime calendar Chinese and get the Gregorian calendar date out from it. So you can go back and forth, which can be handy. I mean, most of you won't need this, but I don't know. If any of you are doing like religious calendars or anything like that, it's useful. All right, so let's also cover time. So time is based on the day length, which is one rotation of the Earth around its axis. You probably all knew this, but if there are any dummies in the room. So a day has 24 hours. The first hour is the 0 hour. Last hour is 23. Daytime does not let you pass 24. An hour is 60 minutes. Most of the time, are 60 seconds. And that means a day is 86,400 seconds. Again, most of the time. All right. Atomic clocks are another, I know I'm just switching topics, but it's another thing you need to know about, and it's kind of relevant to something that will come up later. So with an atomic clock, it's basically some physicsy crap that I don't understand. As I was telling some people, I was a music major, so I don't know. It's like atoms and shit. So with an atomic clock, the length of a second never changes, and this is as compared to the old system, which was basically take the length of a day, divide it by 86,400. Now, the length of that day is changing because the Earth is slowing down in its rotation as well as its revolution around the sun. So this TIE standard, which is short for the French abbreviation, and I won't brutalize you with any more of my French, this is an international atomic time standard, but it's not exactly what we use, although what we use is based off this. So that, and it involves this thing, leap seconds, which I really, really hate. So as I mentioned, the Earth's rotation is slowing down, but the length of a second is not slowing down because we've tied it to these atomic clocks, which of course is good. I mean, I'm not complaining about the whole use of atomic clocks. That's great because that makes sciencey stuff much easier because scientists want the length of a second to never change. If it gets slower and slower over time, it becomes harder to report a measurement, like if you're reporting things in nanoseconds or whatever. So that's important. So it's slowing down, so we need to resync midnight. Otherwise, midnight kind of drifts away from the actual middle of the rotation. So what happens is every once in a while, the International Earth Rotation Service is like, hey guys, let's have a leap second. And then I go, oh shit, I have to update DateTime and upload a new release. And generally this happens, they give about 6 months notice. They're just kind of paying attention. Now, in theory, the Earth could rotate faster, so the standard accounts for subtracting, having a negative leap second. That has never happened. So I think right now we're at 34 leap seconds since 1977. And there's going to be one, oh, set your calendars, it's going to be really exciting. On June 30th, the end of this month, 23:59:59, instead of going to the next day, it's going to be 23:59:60. And that, I mean, think of all the things you could do with an extra second in the day. Yeah, I mean, I imagine I'll wake up the next morning just feeling really refreshed. I'll be like, whoo! extra second of sleep. Best night ever. So yeah, so they just kind of happen, and there's no warning. I mean, because this is, it's not predictable, essentially. So that's why they just get announced. Now, there's been discussions about abolishing these and instead moving to leap minutes, which would be awesome because they wouldn't even happen in my lifetime, so I could just forget about it. And there's even been discussion of leap hours. I don't know if any of that will happen. I'm kind of got my fingers crossed for the whole leap minute thing, and just, I don't plan to have kids, so really I don't care. Your kids, those of you who have kids can deal with it, and fuck them, that's what I say. No, I'm sure your kids are really adorable. I'm sure they're awesome. Yeah, breeders. Anyway. All right, so we have TIE, which is the atomic time standard. We have leap seconds, which are my nemesis. And we put the two together, and we have UTC, and I love this acronym, because in English we have Coordinated Universal Time. I lied, more French. And in French we have Temps Universel Coordonné. And apparently the compromise was to use neither acronym. So we have UTC, which I just think is a hilarious example of kind of international diplomacy at work. Let's pick something that works for no one. So UTC is we take TIE, and then we add all the leap seconds we've had so far, and that's the current time. So like I said, we've had 34 leap seconds so far. Going to have another one this summer. This is the first one in 3 years, so I don't know when the next will happen. This is the current world time standard. This is what generally your clock is going to end up synced to. It's certainly what your computer clock is synced to. And probably most of you, and your phones, and probably most of you set the clocks in your house based on that. So generally that's what you're using. Of course, none of us have actual atomic clocks in our house, so it's not like we're that precise. That'd be cool, but I did buy this clock radio that was supposed to sync with some broadcast signal of atomic time, and it just doesn't work. Every time I sync it, it comes up with some random time, so I don't know. Apparently we haven't mastered this whole radio broadcast thing. Okay, so right, current world standard, UTC is based on time in Greenwich, England, and then all the other time zones in the world are basically described as an offset from UTC. So we can say it's 5 hours forward. You take UTC, add 5 hours, or take UTC, subtract 12 hours. There are time zones that are like 12 and a half hours, stuff like that. So this is my warning about time zones, is they're just like the stupidest thing ever because politicians are involved. And as we've already seen, politicians can't even come up with an acronym that works. So anything more complicated like a time zone, we're just doomed. It's just disaster. So they change all the time, and often for not very good reasons. So the last time the US time zone system was changed, our glorious leader, long may he reign, Heil George Bush, was in office, and his reasoning was that this was going to save energy. Of course, it doesn't do shit. It just means that a bunch of programmers have to update or really sysadmins have to update their time zone database. So really, it just wastes a lot of time and probably costs money because now, all these sysadmins around the world are going, oh crap, I have to make sure this is updated or the system's going to be screwed up. So as far as I can tell, achieve nothing, but that's pretty much what politics is for. So they change all the time. I have seen examples where countries will introduce time zone changes that take effect like the day or the week after they're voted in. It's a real nightmare. This happened, I think, in Argentina. Is Brian Fraser here? I know there's an Argentinian program here. Well, your government's stupid, Brian. Really, really freaking stupid. At least in the US, we had a few months' notice. So, yeah, and this happens often. At one point, I think it was Israel was like, we should make the time zones sync to Shabbat and the end of day Friday, which would just be an even bigger nightmare. And in fact, in Saudi Arabia, the time zones match up with the Islamic calendar. It's so horrible. So we have this standard that we use, or most of us use. It's called the Olsen time zone database. You might see it on your system and user share zone info. And some systems, I think there's actually the name Olsen in the path. It's called Olsen because the guy who started this project was Arthur David Olsen, who is now retired from the project after working on it for like 30 years. And I think we all owe him a big debt, because I mean, a lot of free software work is really, really thankless, and this is just like the ultimate thankless work, is dealing with all these stupid political changes. And he did tons of great research on the history of time zone changes. I mean, not just him, lots of people contributed. But really, you know, like, I think most of you probably have no idea where this stuff comes from. And it's actually this dude who started this project, and it's, you know, kind of spread to every computer in the world, except of course Microsoft. They just have to do their own thing because they're Microsoft. They're like, oh, there's a great standard open source of data with all the time zones? No. Why would we use that? Let's make our own shit up. So I don't know exactly what Microsoft uses. They use different names. Somebody who's a Windows user has contributed code to support that for the DateTime module, and I'm really appreciative of that. But at the same time, I just have no idea why Microsoft does this. So let's talk about time zones. As I mentioned, it's an offset from UTC. Typically, it's just going to be hours and minutes. I think in theory, it could include seconds, but for modern time zones, nobody does that. If you look at historical time zones, they do that. Yeah, exactly. So way back in the day, it was just based on the local position of the sun at noon. So here in Madison, we're currently at -05:00, so that says subtract 5 hours and 0 minutes from the current UTC time to get our current local time. So time zones also have a name, and these names come from the Olsen database. And typically the names are a continent or an ocean plus a major city, and the city is generally the most populated city at the time the zone was created. And sometimes that's changed, and then people complain about it on the time zone list. And even this gets political, of course, because everything has to get political. And people are like, well, this city is bigger now, you should change it. And they were like, the time zone database people were but every Unix system in the world is using this other name. Anyway. So the zone we're in right now is called America/Chicago. So America is the continent. Chicago is the most populated city in the zone. I think that's still true. Another one might be Asia Taipei. There's Asia Shanghai, blah, blah, blah. Pacific Fiji, so that's an example of one that's using an ocean name because not every city is on a continent. And then there are some three-part names where basically a three-part name is a sign that the country has just decided to really fuck things up. So you get America, Argentina. Argentina has like 8 or 9 of its own time zones. It's just like one country. Why does it need so many time zones? Actually, the U.S. has its own because we have America, Indiana, and then like 5 time zones. And then I think it's Arizona has its own little mess. And so, you know, it's not just Argentina. The whole world has problems. So what these name zones are is just a collection of rules. And it's a rule that kind of defines all the historical changes and then also defines the future changes. And the changes are the daylight saving time changes. These rules also define short names like CDT. So the rule might be something like, I can't even remember. This is the funny thing. So I've worked on this stuff for years and years. And I always am surprised when our daylight saving time change happens. I'm like, oh shit, really? If only there was some software that would tell me this. So I think our last change was sometime in March. And so the database says something like, every March, on the first Sunday in March, add 1 hour. And then every November on the second Sunday in November, subtract 1 hour, or however it works. Spring forward, fall back, yeah. So that's what the rules are. And it also lists all the historical changes. There's been a lot of historical changes throughout the world. The US used to, for example, during World War II, we had like wartime where we stopped using DST. And then when it was over, we briefly had peacetime. And then it just went back to standard and daylight time. So yeah, there's a lot of historical stuff. It's actually kind of interesting, if you're interested in some of the history of this stuff, to read. There's a lot of comments in the Olsen database source. The version on your systems gets compiled to a binary form, but the source actually has all this really, like, they've done just amazing amounts of research to figure all this stuff out. Now, of course, some zones around the world don't actually implement DST. Good for them, because it's really stupid. Thank you. Thank you, brother. So their rules are just like, here's the offset, here's the short name forever. That could change because remember, politicians are involved and it's like, hey, I could fiddle with this even though it's working perfectly. Now, one thing I really want to emphasize is that there's no guarantee that these short names are unique. So for example, a lot of people in the US will refer to like EST, which is the standard time on the East Coast. But Australia at one point also had an EST. So if you're dealing with users coming to your site from all around the world and you want to ask them to pick a time zone, you can't just give them these short names and expect them to get good data. What you need to do instead, well, I'll talk about that a little later. But one thing I want to emphasize, you can use the short names for display because when somebody's picked a time zone, if you use EST, it's really clear to them. But you can't use it to have them tell you their time zone. All right. So this is kind of a pain, is getting users to pick time zones. The Olsen database, if you just if you get a list of all the zones, there's, I don't know, 300 or something. And a lot of them are purely historical. So basically, if you look at kind of the history of time zones, what you see is it kind of started with just local mean time, which is every city just looked at the sundial and decided when noon was, and that was when noon was. And then it kind of grew more and more into larger and larger units using the same time zone. So now in the modern system in the US, we just have 4-ish major time zones plus Indiana and Arizona and of course Hawaii and Alaska. But prior to that, 50, 70 years ago, there was a lot more. So for example, we have America's Chicago right here now, but at one point there was this Menominee time zone that was different from Chicago for some reason. So the Olsen the database has all of these historical names, but it's not always clear which ones are historical only and which one are modern. And I haven't written an API for just saying, show me the list of time zones that are actually in use. I mean, the Olsen time zone database doesn't have that information, so I would need to add it or figure out somehow, and I'm not sure if I can. I'm not exactly sure what things like GNOME do when you pick your time zone. It shows you that nice little map. Anyway, so if somebody ever wants to work on this would be awesome to have a really nice way of saying, okay, what continent are you on? Or maybe it could use geolocation information and guess at your time zone, but only pick the current one. So we could not show users like American Menominee, which they really don't know anything about. Yeah.
Astrology software that has that.
Oh yeah, the astrology software. Oh, those bastards. The reason I say those bastards, there's some of this data comes from some astrology software. I think, no, it wasn't the software makers. They published a book. And so then they sued Arthur David Olsen for using this data in the time zone database. So astrology, besides being a bunch of hooey, is also done by people who are greedy bastards. So that's what I have to say about astrology. But yeah, no, the software might have a good system for doing this, but it's probably closed source.
I just claim all knowledge.
Okay. Oh, I'd love to know how they do it, but if it's closed source, it doesn't really help. And I'm sure and it's really easy if you're just in the US, you can just show like 6 time zones. But if you want to do this worldwide, it's a little bit of a challenge. And again, new time zones get created semi-regularly. I mean, that's why this time zone database releases maybe 10, 12 times a year. And often it's new time zones or changes to existing ones. All right, how am I doing on time? I have about 25 minutes. Well, we'll see how this goes. So DateTime supports all of this. So you can make an object, that's the start time of this talk, in this local time zone, America's Chicago. If we print out the DateTime, it prints out that string. We can change it to Asia Taipei. I use Taipei because my wife's from Taiwan, and I like Taipei. I like Taiwan. So, and then it tells you, okay, that's the time it was local time in Taipei at the start of this talk. So there's probably not many people streaming this from Taipei, is my guess. But ni hao, pangyo, if you are. All right, there's this thing DateTime supports called the floating time zone, which can be really useful. So basically, it's kind of like no time zone. And what happens is, so if we do this, if we set the time zone to floating, then it's not going to change the local time. And if we set it from floating, it won't change the local time. It also ignores leap seconds because you can't do leap seconds without knowing the time zone. This can be useful if you don't care about time zones. It just makes all your date math much simpler. Oh, of course. I always like talk about what's on the next slide and then remember, oh, the next slide has the thing I talked about. So right, so we create a time zone object, datetime object, set the time zone to floating. Oh shit, I left out the hour, minute, second part. Imagine that's there. So we say, that, print out the datetime.
That's about all the accuracy you have anyway.
Okay, so we print it out, it gives you the local time. This is the floating time zone. We set the time zone to Asia Taipei. It does not change the local time. So this can be useful for certain things. All right, let's talk about epochs. You've all probably heard the term epoch and the Unix epoch. So all an epoch means in this context, and we're not talking about like epoch win or, that sort of epoch. This is a different epoch. All it means is just a starting point for a calendar. So when I talked about the Gregorian calendar starting on year 1, January 1st, that's the Gregorian calendar's epoch. The Unix epoch is January 1st, 1970 at midnight UTC. They're very specific about it. The Unix epoch is counted, well, my voice is going to give out. We'll see if I make it to the end of this talk. At the end, it could be like, all right. The Unix epoch is counted in seconds from that start time. And it's sort of UTC because if you read the POSIX spec, it says we should skip leap seconds, and this causes some fun things like when the leap second happens at the end of this month, if you print out your clock and you're syncing to NTP, you might see it like repeat 59, the 59th second, like for 2 seconds, or jump backwards or something like that. So it's mostly UTC. Close. It won't go backwards? Okay, I think it just repeats then. All right. So DateTime can calculate the epoch for you. You give it a DateTime. You ask it for the epoch. This is in UTC, even though the time zone is America, Chicago, just so people know. So here's another problem we have. It's the Y2.038K problem. So, although actually, with most Perl, if you're using modern Perl, less of a problem. So the Unix epoch will no longer fit into a 32-bit integer as of this time in 2038. You might think, well, that's quite a ways in the future, but actually it could bite you now if you're calculating 30-year mortgages or things like that that involve looking at future dates. Now, thanks to Michael Schwern's hard work, or I don't know how hard it was, he did work, that's all I know. As a Perl 512, no, I think it actually was hard work, I'm just joking. Perl uses a 64-bit integer for the epoch internally, no matter what platform you're on, whether you compile with 32-bit ints or not. So this problem is mostly averted, and I'm sure all of you are using a reasonably modern Perl and not Perl 588, right? Yeah. All right, so as long as you upgrade before 2038, maybe you'll be okay. Or you'll be using Perl 6 then. So just something to be aware of. All right. And I've kind of alluded to this. There's a big ecosystem of DateTime modules. So datetime.pm is kind of the core, and there's datetime time zone, datetime locale that work together to do the time zone stuff, the locale stuff I showed earlier. There's a lot of formatters and parsers. So you can say there's like datetime format MySQL. You can use it to parse the format that MySQL gives back. You can use it to render a datetime object in the format MySQL expects. There's a lot of formatters, probably 20, 30 or more on CPAN. So if you're trying to parse a specific format, I would strongly suggest you look for a parser on CPAN first before you write your own. If you want to write your own module to do this, it's really quite trivial. There's a lot of other calendars that I mentioned. Like I mentioned, we have Chinese, Hebrew, Japanese. I think there's Islamic, I can't remember. If there's not, you could write it. We have the Discordian calendar, very, very useful. There's also event and recurrence modules, which I'm not going to really talk about because it's kind of a niche specialty thing. But you can have something that represents a recurrence of like every Monday from the beginning of the year to the end of the year. This is really useful, for example, for representing meetings. It's also useful for holidays. For example, You can say, when is the next Easter, or give me all the Easters from 2000 through 2015, something like that. So things like that are really useful, and these are events and recurrences. But most people don't need to use them. There's also a DateTime span module, which can represent kind of a span of time. So from the beginning of this talk till the end of it, and then you can ask, does it contain this particular date time? Does it overlap with another span? There's also a module for sets of date times, and then there's a module for sets of spans. So all of this can be really useful if you need it, but I'm not going to show too much because, again, these are kind of specialized things, and if you need it, well, you'll learn about it. And then there's also random modules in the DateTime X namespace, which is where I make people put stuff if I don't feel like it kind of fits into these other categories. And there's just random stuff in there which might be useful. So just if you have a DateTime related problem, look on CPAN first. There's more than just the core DateTime module. There's a lot of good stuff. It's CPAN, so there's a lot of bad stuff. But there might be, even the bad stuff might solve your problem well enough that you don't have to write it yourself. And this is Perl, and if you're writing everything yourself, you're doing it wrong. So now I just want to talk about kind of some recommendations and some gotchas that people encounter when using DateTime. These are problems that come up on the DateTime mailing list semi-regularly. So by coming to this presentation, if those of you who are still awake and capable of receiving information might avoid some of these problems. And also I'm going to talk about the screwed up things I did, all the mistakes I made. So there's no DateTime date class, and there really should be. The DateTime object always has years, minutes, dates, hours, years, months, days, hours, minutes, seconds. It would be nice if there was a date only class and you wouldn't have to worry about time zones and stuff. The way to kind of get around this, if you just want to work with dates and do date math and not worry about times, use the floating time zone, so then you don't have to worry about any sort of leap seconds. You don't have to worry about DST changes. And then when you do math, you can use the delta MD and the delta days module. MD is months and days. So you can ask it, what's the difference in months and days between these two dates? What's the difference just in days? The default subtraction gets all the units. So days, months, minutes, seconds. So that's my recommendation if you just need to do date-only work. So here's an example of calculating the difference between two dates. So we have today's date, we have my birth date. Remember that date and send me gifts. Cash is preferred. So again, like I said, we're going to use the floating time zone so we don't have to worry about stuff. And we're going to call delta days to get the difference in days, and that returns a DateTime duration object. And then we can ask, okay, and the reason I have to use this in units days thing, which looks kind of horrible, I'll talk about that in a second. And we can find out, okay, it's 14,071 days. That makes me feel old. Jeez. When you put it like that. So, yeah, so that in units thing. Some complete moron created this module, and I wish I could go back in time and just kick his ass, but then I might not be standing here today. So internally, it stores months, days, minutes, seconds, and nanoseconds. And then it has these methods, years, months, blah, blah, blah. What happens is if I had just called days in that previous example, it's just going to tell me the days excluding the number of weeks. So it calculates that 14,071 days is what, 220 weeks? And then it'll tell me, oh, there's only one day. And this confuses people every time because, of course, it's absolutely terrible. But this is also the other problem with CPAN is I know a lot of people are using DateTime, and if I just change this so these methods return what they should have returned in the first place, instead of now the new people to DateTime screaming at me that this API sucks, I'm going to get 1,000 times as many people screaming at me that I broke their production code. So there's just no winning. So much later in the lifetime of DateTime duration, I added this in units method, which will actually give you what you want. So just be warned that you probably want in units rather than the days, the methods that actually make sense. Sorry. Oh, yeah, so as usual, I went ahead of my slides. So if we do the math that I did before, from my birthday to today, and then we just ask the duration object for days, it says 1. What? But then if we ask it for weeks, so it's 2010 weeks and 1 day. But then if we just ask it for only days, with the units method, we get the same answer. Oops. So, all right. So yeah, DateTime math is really hard. Even not just Barbie, but I think it's hard too. So it's pretty difficult. So first question is, how long is a month? The answer is, it depends. So if we do this, we create a DateTime object representing February 1st of 2009. We add 28 days. We get March 1st. We add 28 days again. We get March 29th. This is very confusing. So let's try this again. So we're going to create January 30th of 2009. We're going to add 1 month. Wait, what happened? We skipped February. And then we add another month, and now we're in April. Wait, let's try this again. So we're going to create January 30th. We're going to add a month, but then we're going to tell DateTime duration how we want it to handle end of month boundaries. We're going to say the default is just a wrap. We're going to say limit it, and if you tell it to limit, then it will never go past the month it ends up in. And then we add another month, and instead of being on the last day of the month, we're on March 28th. There's no right answer. All of these answers were right. The problem is you actually have to know what you want when you do this. And this is why I say DateTime math is hard, because people are like, why doesn't it just do the right thing? And then the next person emails me and is like, why doesn't it just do the right thing? And they're asking for something else. So no winning. You just have to know that this problem exists and you're going to have to deal with it. So yeah, deal with it. How long is a day? You'd think this would be simple. All right, so we create, oh, this is when the time zone changes. Create November 4th, 2012 at midnight in America, Chicago. That's our current time zone. This is when we're around the time when we're going to have a DST change. So if we print out the date time, we get this, which is exactly what we'd expect. We add an hour. Okay, we went from midnight to 1 o'clock. We add an hour. It's what? What happened? Okay, so what happened is we fell back as part of the DST change. So adding an hour, it did add an hour. This 1 o'clock is not the same as this 1 o'clock. This is one of the reasons I recommend you use floating, or later I'll also mention just using UTC for your math.
Isn't the transition at 2 a.m., 3 a.m.?
Right, so there's no 2 a.m. No, is it? I don't think so.
I always thought it was like when you roll back, when you get to 3 o'clock, it goes back to 2 o'clock. Or it goes from 2
Okay, we can check this later. The principle remains the same. Okay, March 11th of 2012, we're going to spring forward. So it's midnight, we add an hour, we get 1 o'clock, we add another hour, we get 3 o'clock. So how many hours are there in a day? I don't know, 24-ish. There's another fun thing that can happen to you with DateTime. So it's the day before a DST change, March 10th. The hour is 2 a.m. Suddenly, okay. Suddenly we add a day, and DateTime's going to throw an exception. It's going to say invalid local time for blah, blah, blah. The problem is there's no 2 a.m., or if Darren's right, there's no 3 a.m., but I think I'm right. There's no 2 a.m. on that particular date in that particular time zone. And really, there's nothing, there's no right answer. Again, I mean, I could have it like move forward to 3 a.m., or I could have it move backward to 1 a.m., but it just sucks. Don't be the guy in the second row, even though you're in the first row. All right. Another issue is that the order that we do the math in matters. So if we add months and days, it matters what order. So we have February 28th of 2011, not a leap year. We add months and days. Now, depending on what DateTime does internally, we could have two different results. In this case, we come up with April 1st. What happened is internally, it adds the days first, which gets us to March 1st, and then it adds the month, which gets us to April 1st. If it did it the other way around, if we had the month first, then we get to March 28th, and then we add the day, we get to March 29th. Again, there's no right answer. If you want to force it to, oh, I thought I showed this. If you want to force a specific order, you could just do add months 1, and then do another call, add days 1, or whatever order you want. So you can do multiple calls to add to force it to do what you want. But again, these are all things you're just going to have to deal with because there's no one right answer. Everything about this, it just sucks. Another fun property of DateTime math is that it's not always reversible when you cross daylight saving time transitions. So we can take 2 date times, subtract them, and get a duration, and then we can add that duration back to this one which was being subtracted. I don't know, what do you call this in mathy terms? The subtractee or something, whatever. Subtractand? Subtrahend. Wow, math is really confusing. I was a music major, as I mentioned. So you add it back, and it turns out it doesn't equal what we started from. And this is normal and expected. And then there's even more fun. What do we do if we have a date during daylight savings time, and then we subtract a date which isn't in daylight saving time? Do we include that hour transition, either added or subtracted, in the resulting duration? Do we not? DateTime tries to come up with sane answers for this. And I think it actually mostly does a reasonable job of DWIMing, but again, it's just something you need to deal with. There's also leap years, there's also leap seconds. All of these can affect your DateTime math. One thing I really want to point out is this is kind of an anti-pattern. Somebody wrote to the list and was like, this doesn't work. Always use the add methods or the delta date method, subtract methods to do the math. Somebody was trying to do this. He was calling set, getting the existing day, and adding 1 to it. Okay, this doesn't work for hopefully obvious reasons. If it's the last day of the month, you're going to get, January 32nd or whatever. 32nd, what is that? Geez, I don't even know English. 32nd, and that's not a valid date, and then DateTime's going to blow up and say you're a moron. So instead, use the add method. If you just call add days 1, it will do the right thing. So don't use set to do math. Use set to set. My other recommendation, like I said earlier, use the floating time zone if you can. If you can use it for all your operations, then that's good. Otherwise, you could try just using UTC. So you could convert all your dates to UTC internally, do all the math, and then change it back to the user's time zone for the presentation layer. The reason this can be better is that UTC has no DST changes, which gets rid of a whole class of problems of like invalid local times and 23 and 25-hour days, things like that. Question? Yeah, UTC is, the question was, is UTC a time zone name? The answer is yes. Yes, question?
You're saying use UTC for the calculations and then convert it to whatever you want displayed.
So the question was, am I saying use UTC for calculations and then convert on display? Yes, that's exactly what I'm saying. So all your internal stuff is UTC, then you go to present it to the user and you call set time zone, America, Chicago, wherever they are, and show them that value. How am I doing on time? When does this end? In 7 minutes. Oh, crap. I talk too much. That's the problem. Anyway, we'll see how far we get. There's also an issue with ambiguous local times. So, for example, during the DST change on October 26th at 1:30, there's 2 1:30s on that day. So if you just tell DateTime that you want 1:30, it doesn't know which one you want. Again, you could create it in UTC and then set the time zone. What happens is that DateTime just always picks the latest UTC time when there's ambiguity. That's just kind of an artifact of the internals, but it's documented to do that, so that won't change. But it's still confusing. So my recommendation, just always store your date times as floating or UTC, if you can possibly do that. Otherwise, store them as a date time plus a time zone. So for example, Postgres has this data type timestamp with TZ. What you don't want to do is just store it in your database with your local time, and then maybe your server moves and now you're storing it with a different local time, something like that. Don't rely on the system to do it. Be very explicit. And then just use time zones for presentation to users. So everything's in UTC in the database. You pull it back, you know the users in Asia Taipei, you give them their local time. So there's also some issue. Yeah, question.
You had a point in there, don't store epoch.
Oh, right. Yeah, I didn't cover that. I'm trying to rush. So I really don't recommend storing epochs because, well, why do I recommend that? I don't know. Some people try to do things where they just use the epoch and they start adding seconds to it and try to do the math that way. And storing the epoch could be okay as long as you're very aware of any issues. It's just not good for math and things like that. It's also like if you want to do something like, basically one reason not to store an epoch, say, in your database is if you want to get a range of, say, the beginning of the month to the end of the month, you're going to have to calculate that all in your app, turn it into the epoch time, then use that when you pass it to the database. It just becomes kind of a pain. Something smells fried. Are any of you frying food in here? No. All right, so a few performance tricks. DateTime can be a little slow when you're creating many, many thousands of DateTimes. But first, my rules of optimization, which are don't optimize. Don't optimize, I'm serious. If you have to optimize, benchmark first so that you know kind of what you're aiming, what your current performance is and see what you can aim at. And don't benchmark without profiling first. If you're going to benchmark some small part of your app, you need to know which part of your app is going slow. Don't guess because you'll get it wrong, especially if you're my coworker. It's just not optimizing everything without benchmarking. It is driving me crazy. He's not here right now. So, and then the final rule is just C number one, which is don't optimize. But if you need to optimize, one really, really easy thing to do, and this isn't particularly dangerous, is just cache the time zone object. So when you pass a string for the time zone to the DateTime constructor, it calls DateTime time zone new. And every time you call that, it has to look it up. Now, the objects themselves are singletons, but there's still a lookup process, and it makes sure it's a valid name and all that. You can just skip all that. You can just make the time zone once. Instead of passing a name, you can pass the object, and that'll work well. And that actually was like a nice little fix, for example, for Bugzilla. They're having some performance issues. In particular, one thing I haven't mentioned, you can pass the name local, just as all lowercase, and it'll figure out your machine's current local time zone. That can be really slow. So if you need the local time zone, then you definitely want to cache it. That's an easy and safe one. Now, I did say use a parser before, but if you're dealing with input of like 1 million records and you know that they're all valid and all in the same format, then you could skip using a parser class or parser object, and instead just write your own regex or something like that. Again, this is when you know you have a lot of data that you've already validated somehow and you trust it. So this can be one way to save a little time, also relatively safe. Again, if you know your data is valid, for whatever reason they really know, because a lot of people say they know, but they don't really know, and they're kind of lying, and they're just, there's going to be problems down the line. But if you know and you're sure, then you can do this little hack. If you set this, it turns off params validates validation, which DateTime uses, and that makes constructors a lot faster. Again, this is when you know the data is coming from a source you trust, because if you do this and then pass like month equals 14, I don't know what's going to happen. It's not going to work, and it's not my fault, and I don't want to hear about it. So, oh, well, we made it with 1 minute to spare. I'm happy to take some questions, and if it takes too long, you can talk to me out in the hall. But yeah, questions.
I was going to ask you about the legal issue with the Olsen database.
Oh, so the question is, what happened with the lawsuit against the Olsen database? Yeah, it was thrown out, I think. So take that, astrologers.
There was some question about, they moved the database so that it wasn't in.
Yeah, it's part of IANA. The database is now an IANA project, International Assignment of, I don't know what it is. It's some standards body. And I think they helped with the legal case. But the legal case is not an issue now, so don't worry about it. Yeah?
How is DateTime storing things itself?
So the question was, how is DateTime storing things itself? Internally, what it stores is something called radidia, which is Latin for something or other. I never took Latin. It's an epic system. It comes from Calendrical Calculations, which is a book on date and time math. And so it stores number of days since the beginning of the Gregorian calendar, and that number can be positive or negative. And then for the time, it just stores number of seconds in the current day. So yeah, that's how it does it. But that, you never need to worry about that unless you're writing another calendar module. So it doesn't really expose that. Other questions? You have no questions? You all understood everything I said? You're going to go back and write beautiful DateTime code and not do things which make me sad. Well, thank you. Thanks very much.